this week is a bit unusual because I am away, but next week I should be back in person. And I'll try and go through as many questions as I can today for this paper. And then hopefully next week we will start on a new paper, okay? You should have this paper from last week. If you don't, there should be some extra copies outside, which I've asked Alaf to make. So if you don't have this paper, you can grab it from outside, yeah? But you should have it from last week anyway. Okay, so I'm going to continue where we left off from last week. So I kind of finished off on this question, and then I told you that you can rearrange your equations to find the volume of H2. This was the all-in-one fraction method, but if you're not comfortable with these, you could have done it step by step and still get to the answer, the same answer. Okay, now this was where I left off. Magnesium is a good reducing agent because metals, or I should say reactive metals, like to lose electrons. Reactive metals like to be oxidized. As you know, reducing agents itself get oxidized. So reactive metals are good reducing agent. What is a test for reducing agent? Reducing agent needs oxidizing agent. So when you are asked about this kind of questions, you really need to think about your oxidizing agents. And I was just showing the other class that in the syllabus under redox. So this is the 2022 syllabus under 6.2 redox. Describe the use of potassium iodide to test for oxidizing agent. So that's because potassium iodide is a reducing agent. You use it to test for oxidizing agent. If you have test for reducing agent, you have to use acidified potassium manganese 7. Potassium manganese 7 acidified is an oxidizing agent. You use it to test for reducing agent. So essentially, what you want is this acidified KMnO4. But what I want you to focus on is the words. If you use the words, if they ask you to name, you have to give the complete correct name with the correct Roman numeral as well. Okay? So I'm just gonna say use acidified KMnO4. Use acidified KMnO4. No acid, no redox. It has to be acidified potassium manganate 7. So VII. That is using words, or you can use the formula. Generally, I prefer using the formula because they're so much faster. Observations, it turns from purple to colorless. So purple is the KMnO4. The colorless is when it will go to kind of like pale pink, which is manganese plus 2. And that is your manganese 2 plus aqueous. This is your MnO4 minus aqueous acidified. Okay? And I mean, you must have done this redox titration at least once before. I mean, this is a very common redox titration, not only in practical, but also an alternative to practical, and also in theory, as this is a very common oxidizing agent. Okay, everyone managed to get it done? All good? Can continue? I can't actually see you, so someone need to shout out, yeah? Okay, now let's continue on this. Now, alkanes are homologous series, and they told you that the boiling point, melting point, and density increase as the number of carbon atom increases. This one you can relate to fractional distillation of crude oil. You know, the one like 4 to 5 marks essay, the one where you have to describe the process, like top fractions. And then it's like that, and then, you know, different fractions. And what you have is you have crude oil at the bottom, and then you heat it, and then they will go up as a gas, so you boil it, and then they will condense. So the top fraction is the shortest carbon chain, the lightest, the shortest carbon chain, the one that boils first, the one that has lowest density will be on top. The one at the bottom will be the heavy one, the high density, the very high boiling point, the one which is going to be like liquid or solid, they are all towards the bottom. Now they want other physical property. So two things that are very important. Physical property. cannot talk about formula, cannot talk about chemical property, must be physical property, must be other, cannot use this, or this. And then this is the one that a lot of people get stuck with because they don't know what is happening. They're like, but they already given me everything. No, they haven't. If you look at the syllabus, they haven't. It's all stated in the syllabus. That's why I said, if people don't know the syllabus, you are going to struggle a lot, okay? This is under 2022 syllabus, organic chemistry. You see this thing here, alkanes, melting and boiling point increase, viscosity, viscosity, V-I-S-C-O-S-I-T-Y. Stated in the syllabus, so this is actually viscosity. There is no many other answer, there's only viscosity, okay? Viscosity is like honey. You know when you eat honey like sugar is very sticky because it's very viscous. When something is viscous, it doesn't flow easily. It doesn't flow easily. This is the adjective, viscous. This is the noun, the property. As you go to bitumen, bitumen is used to pave the road surface. Before it hardened to pave the road surface, they have to melt it. It comes as a gooey liquid, very, very gooey kind of liquid, very, very viscous. That's because further down the chain, further down the fractionating column, at the bottom, it becomes more and more viscous as the carbon chain gets longer and longer, okay? As a result of stronger intermolecular forces. So viscosity is one thing that will increase with longer carbon chains. Other characteristics, if you think about CH4 is methane, then the next one is called ethane, that is C2H6. The next one is C3H8, that is called propane. And then the next one, C4H10, is called butane. Now you should know your naming and you should know your general formula. They all have the same general formula. So for instance, your alkanes will be CnH2n. As long as they belong to the same homologous series, they will have the same general formula. This is CnH2n plus 2 because that is for the family of alkanes. The other thing you can be thinking about would be, you see this is CH4. When you go to C2H6, you have added CH2. The next one have added CH2. The next one have added CH2. Add one carbon, add two hydrogens. You can follow with alkene as well if you want to. It will still differ by CH2. So each member in the series, they differ by CH2 or 14 mass units. Because each carbon is 12 mass units plus 2 times 1. That's why each of them differ by CH2, each of them differ by 14 mass units. Okay? Now, the next one, two typical reactions of alkanes are combustions and cracking. Combustions, remember last week we talked about complete combustions. Complete combustions will give you CO2 and H2O. Cracking is something that we will talk about again later, but it's basically break long chain hydrocarbons. So we need to break up the long chain hydrocarbons into shorter chain hydrocarbons. So you want it smaller, you want it shorter chains, and the reason for it is because it's more valuable. There's more money in it, and it's more useful, it is more valuable rather than as a long hydrocarbon chain. We want it as a shorter hydrocarbon chain. So here, they're asking you for another typical reaction of alkanes. I remember a few weeks ago when we started doing papers, we talked about one of these reactions of alkanes. It is called substitution. Substitution. So substitution means you replace one atom with another atom. For instance, you have CH4, and then you add with Cl2. What you're going to get is you will replace one of the hydrogens with a chloride. You replace any of these hydrogen with a chloride. Replacement, replace means substitute. Substitution means replacement of one atom or one group with another atoms, and you will be left with HCl. balance equations. This overall reaction is called substitution, and you need UV light. UV refers to ultraviolet light. Sometimes the question will say sunlight. Sunlight will also work. Sunlight has your ultraviolet light, yeah? So your reactant here and the reactant, and by the way, state the name of another typical chemical reaction and the reactant, state the name. So cannot give Cl2, must be chlorine, okay? Now you can also give bromine as well, but you cannot give Br2 because they want the name. When you read the question, they say they want the name. They don't want formula if you read the question, of course, all right? I talked earlier about cracking when we want to break long chain hydrocarbons into shorter chain hydrocarbons. Here they want the conditions. There are two conditions required for cracking, as stated in your syllabus. You need very high temperature because we need to break covalent bonds. We also need catalysts because catalysts will help to make the reaction faster. It will help to lower the activation energy for the reaction to happen, and therefore reaction can happen a lot faster. All right, so this catalyst is typically Al2O3 or SiO2. Typically, they're just looking for catalyst at high temperature, to be honest. They, of course, want you to write an equation, C13H28. You crack it, produce an alkene with 4 carbon atoms. So alkene is CnH2n plus H2n, and then n equal to 4. So that means C4H8. And then they say only one other hydrocarbons. Hydrocarbons is a very common definition in O level. Hydrocarbons, it contains hydrogens and carbon atoms only, because there's only hydrogen and carbon atoms in the molecule, okay? So if you produce these alkenes and the other product must contain carbons and hydrogen only, and there's no other product. 4 and 13, so the difference is 9. 28 and 8, the difference is 20. So that is your CnH2n plus 2. This is your alkane. Oops, can't even spell that properly. Alkane. And then this is your CnH2n. This is your alkene. So long chain, 13 carbons, you cut it up into shorter chain hydrocarbon, which is more valuable. Okay. Now in an exam, however, construct n equations. They don't say the equations because there is more than one answer. Because you could also imagine that instead of getting one of these C4H8, how about if I get 2 of them? Will it still work? Well, I still get alkene. I still get 4 carbon atoms. They don't tell me how many of it. They just say I get this alkene. Okay, and that means the other remaining one will be, if you do the math correctly, there's 8 carbons. So there's remaining 5, and there's 10 remaining because 12 remaining. Because 28 minus 16, we get 12. This is also correct. This is also correct because number 1, you have 2 products. One is alkene with 4 carbons, and the other one is still hydrocarbons. Number 2, you still have balance equations. Balance equation is very, very important. Okay? But usually people will just go for the simplest one, which is just summing up, whatever get left behind, and that's all for that 1 marks and 1 minute. Okay, everyone, okay? Can we continue? Now this one is about empirical formula. Empirical formula is defined as the simplest ratio. Simplest ratio. Yep, simplest whole number ratio. Simplest whole number ratio of atoms. So we have hydrocarbons. Hydrocarbon only contains hydrogen and carbons. So if we have 88.9%, so this must be the remaining out of 100% because the maximum is 100%. So 100 minus 88.9, I get 11.1. These are percentage by mass. So this means out of 100 grams of mass, how many grams is carbon, how many grams is hydrogen. If I want the mole, that is your mass over AR, 88.9 divided by 12, 11.1 divided by 1, and you should get your answer as 77. That doesn't make sense. 7.4. Okay, you cannot leave your answer like this because these are not simplest ratio. So to do the simplest ratio, what I must do really is I divide by the smallest number. The smallest number is 7.4. So on both sides, divide by the smallest number. When you divide by the smallest number, then you're going to get 1. And you're going to get 1.5. Here is where a lot of people thought it's over. Because number 1 mistake, they don't know about this percentage thing. Number 2 mistake, they don't know about having to divide by the smallest number. Number 3 mistake, they don't know their primary school mathematics, which is 1 over 1 is 1, 1 over 2 is 0.5, 1 over 3 is 0.33, 2 over 3 is 0.67. Whenever you get numbers like 0.49, 0.48, or 0.51, 0.52, something very close to 0.33 like 0.3, 0.35, something very close to 0.67 like 0.68, 65, 66, you should be thinking about this number at the bottom. This is called denominator and fractions. 0.5 there is not a whole number. Do not run it up. Do not do anything funny. You want the simplest whole number ratio. So I multiply by 2 both sides because I realized that 0.5 is 1 over 2. So 1 times 2 give me 2. 1.5 times 2 give me 3. Simplest whole number ratio of your atoms. C2H3. Not an easy 2 marks. And this is the ultimate game, really. Do you have what it takes? Identify primary school fractions. These are the numbers you should be looking out for. These are the definitions you should be thinking about. Simplest whole number ratio of atoms. Okay, be very careful here. Now moving on to the next question. So here, this is a redox reaction. Why does it involve oxidation? And why does it involve reduction? So we know about oil rig. If you know oxidation number, you can use it, but they did say refer to the equations. So here, one thing to keep your mind on is that this is lithium metal. This is lithium as an element. Okay? This is zinc iodide. This is not zinc. Do not talk about zinc. This is zinc iodide. What it has is Zn2+, I minus and I minus, ionic compound, zinc iodide. Zn2+, straight from your paper 3 qualitative analysis, straight from your paper 4 qualitative analysis, table of which are never ever given for your paper 4. The table of tests, yeah, not given. So here, this is Li plus and I minus, and here is just Zn. So if I look at that, I can see my lithium become lithium plus. Lithium metal becomes lithium plus. So here, the metal has lost 1 electron. When the metal loses electrons, I write the electrons on the right-hand side. Group 1 metal loses the 1 outer shell electrons, form a +1 cation with a fully filled outer shell. And this is what you call oxidation, is loss of electron. We lose electrons because we have the plus electrons on the right, and this is 0 charge, this is +1 and -1. Equation is balanced. Half equation is balanced. The next one is the zinc, but I start from Zn2+ becoming Zn. Zn2+ becoming Zn. So this is cations, this is the metal. So I must gain electrons. So I do plus electrons on the left-hand side, but this is 0 charge. This is +2, zinc 2+, straight from your test for iron. This is -1. I need 2 electrons. So this is reduction, is gain of electron. Okay, hopefully that makes sense, yeah? And since oxidation and reduction happens together, overall is a redox reaction. And the next one is test for iodide. If you look at the syllabus which I've given you, I think on the second page, there is the test for ions, one of which include iodide, chloride, bromide, iodide. You need acidified, you need aqueous silver nitrate, and the observation you get will be yellow precipitate will form because this is the formation of silver iodides. If you think about your test for chloride, bromide, iodide, so you know that all chlorides are soluble except for silver chloride and also lead 2 chloride. Silver chloride, AgCl, PbCl2, they are both white PPT. AgBr, that is your cream PPT, and actually that is the same color of PbBr2, lead 2 bromide. AgI is yellow PPT, that is also the same color of PbI2. In terms of ionic equations, this is your classic precipitation reactions. They do really like to ask you what type of reaction it is. Silver nitrates. All nitrates are soluble in water, aqueous. You added aqueous solutions. You added a colorless aqueous solution. You added the iodide, which is aqueous solution. And then you get silver iodide, which is yellow PPT. This is called precipitation reactions. The Ag plus and the I minus come together to give you this ionic solid, which is insoluble. Precipitation, because soluble plus soluble give you something which is insoluble. You need to think about salt preparations and how you're going to purify this salt by filtration, by washing with distilled water, by what else? By drying it in between filter paper in order to get a pure dry salt of this insoluble form. Okay, the next one will be displacement. I remember last week I talked about displacement, or the week before. So we know that chlorine, bromine, iodine, this is most reactive. Or I would say more reactive, not most reactive, whereas this one is less reactive. So reactivity of the group 7 decreases down the group 7. So what happened is, the stronger you are, the higher you are in the group 7, you can kick out, you can displace the halogen, which is below you, from the halide. This one is bromine. So this one is Br2 aqueous. This one is iodide, I minus aqueous. So bromine is above iodine in the periodic table. Bromine is more reactive than I2 in the periodic table. Bromine can kick out I2. Bromine can displace I2 from I minus, and again, brown solutions. What is tricky in this question is name. Name the products. Cannot give formula. Okay, the formula will be I2 aqueous. So that will be aqueous iodine. Follow the name of the reactant. I cannot put down I2 aqueous. Follow the name of the other thing, which will be aqueous zinc bromide. Because when I already undergo the redox, I will have, let me just clarify this. Yeah? Hang on, just give me a minute. Let's put this down. So what happened here for this C part 1? So Br2 plus Zni minus, Zni2. The Br2 will displace I2 from the I minus. And what happened is, it will give me that. You should be able to write half equations. You should be able to write half equations for that. If you write half equations, you will see that Br2 becomes Br minus, and that means you must get 2 electrons. So this is your reduction, which is the Br2 gains electrons to become Br minus. On the other hand, the I minus, 2 of them, because I minus and I minus, becoming I2, you must lose 2 electrons. That is your oxidation. Now that reaction happens as a redox because bromine is above iodine in the periodic table, and therefore bromine can displace I2 from I minus. This is not I2, this is I minus. Think about your question earlier. What does that I2 means? It's not I2 as a molecule, it's zinc 2 plus and 2 of the I minus. Year 9 chemical formulations, very simple stuff. Okay. Now, why does aqueous bromine not react with chloride? Well, because chlorine is above bromine in the periodic table. So if you are above that other element in the periodic table, therefore chlorine is more reactive than bromine. If chlorine is more reactive than bromine, I could also say the opposite way around. Bromine is below chlorine in the periodic table. Bromine is less reactive than chlorine, and therefore bromine cannot displace chlorine from chloride. Bromine cannot oxidize chloride to chlorine. Hopefully that makes sense, yeah? Straight to the point, 1 mark only. Everyone okay?
Yes.
Now, question 6. This is about energy profile diagram. For 2 marks, you need to know energy profile diagram is energy against progress of reactions. Sometimes we call this reaction coordinate. Reaction coordinate means what happened from reactants to products, from reactants to products. You got to label reactant, products, and delta H. This is endothermic. That means delta H is greater than 0. It's positive, and that is because your reactants absorb energy from the surrounding, and that is why the surrounding temperature will drop. That is what happened to the surroundings because the reactants absorb energy. When the reactants absorb energy from the surrounding, the products will have more energy because what happened to the reactants? The reactants absorb energy from the surrounding, you take away the energy from the surrounding, and that is why your delta H is from the reactant to the product. Delta H is from the energy level of reactant to the product. Okay. Now I put in my hump like that, and I will put in my reactants and products. Products are on the right, reactants are on the left. What else? They haven't asked for activation energy, so you don't get extra mark for writing activation energy. But I'm just going to put it in here because it's important that you know where is the activation energy. Big E and small a, activation energy. So it means from the start to the top of the peak, from the start to the top of the peak, from the energy level of the reactant to the start to the top of the peak. That is called activation energy. Okay, so just be careful, yeah? You don't get extra mark for labeling activation energy here, but you never know when they're going to ask you to label, yeah? Okay. Now, this next bit is a fixed asset. When I say it's a fixed asset, the first point really is on bond breaking and bond forming, and they always come up, yeah? Why this reaction is endothermic. Now, some students would memorize this kind of thing, and then when it comes to the real thing, and then they forget what is happening. And that's the problem. They forget what is happening, right? So what I want you to do is, you have to remember this equation, yeah? Enthalpy change of reactions is the total energy for bond breaking minus the total energy for bond forming. So it's the bond breaking minus the bond forming. Bond breaking minus the bond forming. They give you the enthalpy change. The reaction is endothermic. Endothermic means it's positive. Positive means big minus small, because big minus small will give you positive. What do I mean by big? I mean the total energy for bond breaking must be greater, must be bigger, must be more than the total energy for bond forming. That is your last point there. But let me just go through the first point. The first point is common, whether the reaction is exo or endo. The first point is factual. Bond breaking is endothermic because when you break bond, you must absorb energy. If you don't absorb energy from the surrounding, you cannot break the bond. You don't have energy, okay? Bond forming is exothermic. So you just have to state these factual stuff, yeah? Because they did say in terms of bond breaking and bond forming. So we're stating the obvious. The second point is based on this formula. Enthalpy change is total energy for bond breaking minus total energy for bond forming. Very important formula, yeah? Sometimes you're asked to do calculations. Sometimes you're just asked on essay like this. I want the overall to be greater than 0. If I want the overall to be positive, I want this to be bigger than this. So therefore, overall delta H is greater than 0 because I can write my own words. I can write in my own words if I know this formula. I want this to be bigger than this, so I will say it. You could also say it the other way around. total energy released for bond forming is lesser, is smaller than the total energy absorbed for bond breaking. Remember, you absorb energy for bond breaking, you release energy for bond forming. So overall delta H is greater than 0 because the total energy absorbed, so you need to absorb for bond breaking, and this one must be greater or much more than the total energy released for bond forming. And that's it really for that kind of essay. Of course, then this essay can change. Why is this reaction overall exothermic? Exothermic means delta H is lesser than 0. If you want this to be lesser than 0, then you would just have smaller minus bigger. So you would just say the total energy absorbed for bond breaking is lesser than the total energy released for bond forming. Then delta H is negative, that is overall exothermic. So this essay is quite easy to manipulate, provided you know that the correct way around to calculate enthalpy change is the total energy for bond breaking minus total energy for bond forming. Write in your own words to get overall positive or negative, and you should be all right. Okay, everyone fine with that? Well, let's try to balance the equation next. So here you have 4 phosphorus. So there is only 1 molecule of it because there is no dotted line in front. So I just need 4 of that pH3 to give me 4 phosphorus. Next up, I have 12 hydrogens. 4 times 3 is 12 hydrogens. Here is 2 in water. I need 12 hydrogens. So I have a 6 H2O. Next up, I will have 10 oxygens. And I will have 6 oxygen. So altogether, I need 16 oxygen atoms. But I have O2 molecule here. I need 16 oxygen to balance the left and the right. So I will have 8 because 8 times 2 is 16 oxygen atoms altogether. Okay. All right. Section B. Okay. I can't go through all the questions in section B. So you're going to choose for me 2 questions that you want me to go through. Okay. Go on, choose the first one that you want me to go through. Which question? Seven, 8, 9, or 10. 7, 8, 9, or 10. Which one? Question 8? Okay. Okay. Question 8. Deduce the molecular formula. Just now we had empirical formula, which was defined as the simplest whole number ratio of atoms. Molecular formula is another year 9 definition. It is the actual number of atoms in one molecule. So it's the actual number of atoms in one molecule. So what happened then is, this is one molecule. Count the atoms. 1, 2, and 3 carbons. Count the hydrogen. 1, 2, 3, 4, 5, 6 hydrogens. And there is 1 oxygen. Can you simplify it any further? No. So the molecular formula is this, but the empirical formula is also this because you cannot simplify it any further. Okay, quite an easy, nice start to the question. Now we use aqueous bromine. We know that this is Br2 aqueous, not Br2 liquid. Br2 liquid is reddish brown liquid because it's the element. The element itself is very dark in color, very dark in color. This thing is light in color because you dissolve it in water already. You dissolve it in water already. Now what happened is, it will go from orange, or sometimes people say orange yellow. If you say orange is also fine, or yellow is also fine. But what happened is, it will go from orange, yellow, orange, or yellow, and then it will go to colorless because you have this thing called alkene. So test with Br2 is test for unsaturation when you have double bond using aqueous bromines, and it will decolorize bromine water. It will turn from orange yellow to colorless. That is the test for carbon-carbon double bonds, because carbon-carbon double bond can undergo addition reactions. Whereas if you test it with alkanes, if you have alkanes and you add in aqueous bromine in the dark, it will remain orange-yellow. It's a negative reaction, no decolorization. It remains orange-yellow because no addition reactions onto alkane chemistry. All right? I'm sure you've done this alkane versus alkene, right? That's for unsaturation before. The next one is, what is a suitable oxidizing agent? You must have done this. This was the first question we did earlier in this session. Do you remember the first thing we did earlier in this session? What is a good oxidizing agent? What is a good oxidizing agent? They don't ask for the name. They don't ask for the formula. You can give the name, you can give the formula, but it has to be correct. It's this thing. Do you remember that? So that is oxidizing agent. That is your purple color reagent. Or I can say, using your words, acidified. The H plus means acidified. And then the KMnO4 is potassium. And then there must be manganate. I leave it up to you, yeah, whether you like using the words or you like using the formula. But regardless, you need to know what it is in words, because sometimes the question will ask you, name the oxidizing agent, name. So this is name, this is suggest, or when they don't give you any specific instruction, you can give formula or you can give the name. It's up to you. All right? And these are all stated in the syllabus, yeah? So this one is not only in the redox topic, it's also in the carboxylic acid topic, which I will show you. Where is it? Alcohols, the carboxylic acid. There you go. Oxidation of ethanol by acidified potassium manganate 7. You notice the words acidified. You notice the word VII. If you can't give it in words, it's game over. If you can't give it in formula, it's also game over as well. All right. Now, the next question is about polymerization. So alkenes undergo addition reactions. So the type of polymerization is called addition. Polymerization. Polymerization means form polymer. Your alkenes initially is this carbon-carbon double bond. Carbon-carbon double bond. This other thing here is alcohol. This is alcohol. When you undergo addition polymerization, you don't touch the alcohol. You only touch the alkene. Addition means the alkene becomes single bond. So I draw the carbon-carbon first. No more double bonds. I have H, 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 and then CH2OH. So I just put in H, 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 CH2OH. Addition, I have lost my carbon-carbon double bond. But I'm not happy because carbon now, 1, 2, and 3 covalent bond. Cannot, carbon cannot 3 covalent bond. So I show open. This is open chain. Why is it open? Because it's polymer. It extends, the chain extends. So now, this is 1 repeat unit. The question says 2 repeat unit. So what do? I just repeat the whole thing again. So there you go. I mean, I work on the screen, so it's easy for me to paste. But what happens? Can you see that from there to there? That is 1 unit. So by repeating this unit again, I have 2 repeat units. Now, one common mistake is people remember one end, people forget the other end. Check your carbon from 4 covalent bonds. 1, 2, 3. Check your carbon from 4 covalent bonds. Open, polymeric chains. Show 2 repeat units, 2 marks, just like that. Of course, you lose the double bonds because now it extends as part of addition polymer. Okay, everyone all good? Now the next one, here it says it reacts with methanoic acid. So this is a carboxylic acid. Carboxylic acid has this COOH and you form ester. So ester comes from alcohol plus carboxylic acid. So just now it was alkene. Alkene undergo addition polymerization, you lose the alkene. Alcohol didn't react. Now the alkene doesn't react because it's the alcohol that reacts. Just now you have CH2OH, CH2OH, but that is the alcohol. You want the ester, and you want to show all the atoms and all the bonds. Must show all the atoms and all the bonds for 1 mark only. Okay. Now that is carboxylic. That is the alcohol. Now this is my carboxylic acid. HCOOH. So what happens when you form ester is the alcohol will lose the H, the carboxylic acid will lose the OH. So you will lose this and you will lose that. What happened is I will combine this to here. So lose that, and I will combine this to here. When you form ester, you must remember that the alcohol loses the H. Okay, the alcohol loses the H, and then the carboxylic acid loses the OH. We are not talking about acid or base properties. We are talking about condensation reaction. This reaction is called condensation reaction. It is not condensation polymerization because I am not forming a polymer. I am forming an ester, but I'm not forming condensation polymer. So I just call it condensation reaction. You're just forming one ester. Condensation reaction to form an ester. I display all the bonds. I have just shown you where the bond is to be, the new bond is to be formed. Is that one? This is an ester, C double bond OO. You can flip the whole molecule around and it will still be C double bond OO. I've just shown it OCO like that. It's an ester. Okay. Now this next question is about weak acid and strong acid. So you can look back at acids, bases, and salts topic. Give the formula: positive ions, all acid, H plus. No question asked, yeah? Should be quite easy, obviously, all right? Now this next one is about methanoic acid. So this is weak acid, and this is strong acid. So why the rate is less? That means slower. Why is the rate slower? For 1 mark, you need to focus on, this is 1 mole per dnq and 1 mole per dnq. Even though the concentration is the same, but then we know that methanoic acid is a weak acid. So what do we know about weak acid? They only partially, so this is about definitions of weak acid actually. They only partially dissociate into H plus ions. Therefore, not as much H plus ions per unit volume as strong acid. So therefore, collide less frequently. So they want to talk about rate of reaction, right? So less successful collision. Now this is only 1 mark here, but sometimes there can be 2 marks. So you need to know how to include all the points in terms of we are looking at the H plus ions coming from the acid and not necessarily just the concentrations of the acid itself. Yeah, so be very careful. As for the last question, this is the most difficult one of all, because if you don't know what you're doing, you will struggle. Okay, this is HCOOH. When I react with magnesium, what happened is I will get that as the anion because lose H plus, Okay, when you lose H plus, you get this. The H is gone and you become a minus. I mean, that is what happened with HCl, right? Become Cl minus and H plus. If you think about it, you lose H and you become a minus. You lose H and you become a minus. This is called methanoate. With 2 carbon, it's called ethanoate, and so on and so forth. So your job now really is the H plus is replaced by Mg, cation ions. The formula of Mg cation ions from a group 2 metal is Mg2 plus. And you have a problem now. The problem is people write down the formula as if they will cancel. But if this is Cl minus and Mg2 plus, you know they don't cancel. But this is not Cl minus, it's just something with a minus 1. It is just something with a minus 1. It doesn't matter what it is, 1 and 2. We look at the charges, and we know how to do a year 9 concept because this is about cancelling out the charges. How many do you have? Well, I am going to get HCO2H plus Mg, and I will get Mg HCO2, 2 of them, because I will have 2 of these minus 1 to cancel 1 of these Mg2 plus. So I will need 2 of that and 1 of the Mg2 plus combined together, and I will get Mg and 2 of that, and I will get hydrogen. This is acid plus metal, giving me metal salt and hydrogen gas, which will, give you a pop sound with a burning splint. And guess what? I have 2 of the acid, 2 of the metanoate, so I need 2 of that, and each of these give me a H plus, so 2 of them give me 2 H plus, and I become H2. Hopefully that makes sense to you, yeah? Okay, I hope that makes sense to you, yeah? So what happened then is, what type of reaction is this? This is very clearly a redox because the H plus become H2. So hopefully you can see that that is gaining of electrons. That is your reductions, which is your gaining of electrons. And then you have Mg becoming Mg2 plus, which is your loss of electrons. That is your oxidation. So this is very clearly a redox reaction. Okay? And they can ask you test for hydrogen gas. They can ask you what do you see. You will see effervescence. You will see bubbles. What else do we see? We see the metal will dissolve away. The metal gets smaller in size because the metal will get consumed, right? So it depends on whether which one is in excess or not, but the metal will get lesser and lesser in amount because they will react and they give you this effervescence. I know it's not asked here, but you never know when the question is going to ask you, right? Whether half equations or observations or equations or the name. The name here is called magnesium metanoate. Magnesium metanoate. I mean, this is the name of, oops, sorry, not ethanoate, but metanoate. We have 2 of them because the charges with the group 2 cation must cancel out. Again, we don't have much time, but I'll go through another question as much as I can. So pick another question. Question? I can't hear anyone. Number nine. Okay, this question is about sulfuric acid, which is H2SO4. This is also about sulfate. Sulfate is the salt that you get from sulfuric acid. Sulfate is also in your paper 3 practical. Sulfate is also in your paper 4 test for sulfate. Now name 2 other raw materials used to make sulfuric acid. You have sulfur, you have oxygen, which come from the air, and you should know the other one is water. Water is required in the final step because you need to dissolve the oleum into water, and then you can get your sulfuric acid. This is required in step 1, where you have sulfur plus oxygen, give you SO2. This is also required in step 2, where you have SO2 plus O2 reversible to give you SO3. Okay, that's in your last step where you have oleum plus water giving you H2SO4. Name the catalyst. Oh, very tricky. Name catalyst. You give V2O5, that is wrong. Name the catalyst. Name the catalyst. Vanadium oxide. That is also wrong because you haven't given the oxidation number of the vanadium. V2O5 is the correct formula, but it's not the name. Vanadium oxide is the correct name, but it's missing the 5. Very, very particular. It's a vanadium 5 plus. It's a vanadium 5 plus and O2 minus, 5 and 2. So it's called V2O5, vanadium 5 oxide. All right. Now, defined electrolysis, you see, definitions like these are the ones that students are like, why in the world did they ask me random stuff like this? It's not random, it's in the syllabus, okay? Lysis means to break. Electro means is to use electricity. So, passing electrical currents. So we need current, electrical current or electricity through molten. You can use molten or aqueous ionic compound as your electrolyte. What is the purpose? That is there's the electron bit, and then the lysis bit is to split. What are we doing? To split them, meaning the ions, into constituent elements. If you realize, we get elements out of electrolysis. All right. So sometimes you get oxygen, sometimes you get hydrogen, sometimes you get the metal. So what we want is constituent means what is it made up of? What is it made up of? Okay. And you should have your own definitions in the textbook, in your notes as well. Yeah. At the cathode, we know about red cat. Red cat means reduction at cathode. Now we know that what is cathode? Cations go to cathode. Cations go to cathode. So which one is the cation? We have H plus, SO42 minus because of dilute sulfuric acid. We also have H plus and OH minus because sulfuric acid is dissolved in water. Now cations, well, one of these will go to both of them will go to the cathode. There is no choice because both of them is H plus. H plus become H2. Positive charge, no charge. You must gain electrons. So gain electrons. So you have 2 hydrogens. So 2H plus, gain 2 electrons. Gaining of electron is reduction. Cations go to cathodes. Reduction happen at cathodes. You get hydrogen gas from these cations. Okay. Now the next thing is 3 marks calculations. So you're going to show by calculations that sodium hydroxide is in excess. If you're doing this kind of thing, you should really try and get a couple of marks along the way. Yeah. So this is solid. This is mass. Why do they give us mass? There are 3 formulas. Mass over mR, concentration times volume, volume of gas divided by 24 dm cubed per mole. This is for gas, that is for solutions, and the other one is given masses. So given the mass, I should really be thinking about my mR. So if you look from the periodic table, why do I need the mR? Because I'm given the mass. I want to find the mole. Okay, so 23 plus 16 plus 1, that is 40. So I could have worked out the mole of NaOH. So the mole of NaOH equal to mass over mR, 0.76 divided by 40. And I get 0.019. Now, one thing is, keep your working tidy. Make sure you label mole. Make sure you have units. Make sure you keep your working tidy, all right? Now, this one is solution. Solution chemistry. This is a volume in cm cube. This is mole per dm cube. Number 1 mistake, people forget to convert cm cube to dm cube. So the mole of sulfuric acid there, I will use N equal to CV. When 20, this is mole per dm cube. I multiply by 45 times 10 to the minus 3 dm cube. Times 10 to the minus 3 means divide by 1,000. It means divide by 1,000. When you press the calculator, it will be 45, the button EXP, and then minus 3. It's either EXP or it's 10 to the power something on your calculator straight away. Okay. And this one, the mole of sulfuric acid will come up to 9 times 10 to the minus 3 mole. And I can show it as 0.009 mole. Okay, now after we do that, the last thing we do is we look at the balance equations. We look at the balance equations. 1 mole of sulfuric acid reacts with 2 mole of NaOH. So we write the statement. 1 mole of H2SO4 needs 2 mole of NaOH. So this is what you put in. This is actual. This is actual and actual. So therefore, 0.009 mole of H2SO4, you need how many mole of NaOH? You would need 2 times 0.009, which is 0.018 mole NaOH. Hope you can follow. You need this much NaOH if you have this much mole of H2SO4 based on the balance equation, which I write down. Now, last but not least, how much NaOH did you put in? You put in 0.019. We use 0.019. We reacted 0.019 mole NaOH. Therefore, more than needed, more than 0.018 mole needed. So if we put in more than what we need, therefore NaOH is in excess. Somewhere along that line, you can do your working anyway, but you will get 1 mark for calculating mass over MR. You get 1 mark for your N equal to CV. You get the last mark for doing the mole ratio correctly. And hopefully that makes sense to you. Okay? Is everyone all good? Okay. I think I've just finished off the question because the other person hasn't come in yet. Ammonium. Ammonium is NH4 plus. Sulfate is SO4 minus. You should be able to get ammonium sulfate as 2 of it because 2 of that cancel out that. Now this is your test for ammonium salt. Test for ammonium, paper 3, paper 4, by the way, paper 1, paper 2 as well. So what you get is the OH minus plus the NH4 plus. The OH minus is the base. You will accept the H plus. This is acting as the acid. You will lose the H plus. OH minus, take away the H plus. NH4 plus, hilang the H plus, and you will get NH3. So they want the names. So obviously you will get ammonia. Obviously you get water, but you also get a salt. This thing is ionic equation. That's why you don't see the sulfate, you don't see the sodium. But the other product is the salt. The remaining things, which is sodium and sulfate. So the remaining thing is just your sodium sulfate. If you write in words, you will get I don't know, sodium hydroxide, which I will write as metal hydroxide. And then I get ammonium salt. Ammonium, bukan ammonia. And then what I'll get is, I will get the metal salt. I will get ammonia. I will get water. The test for ammonium salt, tambah any hydroxide, you kick out ammonia gas test, well, your red limers will turn blue. The gas is ammonia because the ion present is ammonium ion. Okay, so you do get the metal salt. I just don't show it in my ionic equations because ionic equations is just the overall big picture. So they want the name, they don't want the formula. Do read the questions, and that's it for today. Okay, when I see you next week, hopefully you have finished the rest of this paper and we can go through another paper, yeah? Okay, all right, thank you everyone, see you next week. If you didn't manage to copy, I'm gonna upload the PDF on the Google Classroom, yeah, so you can look from there. Okay, bye everyone.